Okay, so today we are starting a new unit, and this is going to be about what are called exponents and some exponent rules, and basically what are exponents, what can we do with them, how do we resolve problems that involve exponents. And so first off, it's probably helpful to know what an exponent is, and that is something like if I show you x squared, put in my pen, x squared, this little number up here in the corner is an exponent. That is what this little number is. And an exponent tells you essentially how many of the base, this is called the base, there are being multiplied together. So, for example, this x to the power of 2, where there's an exponent of 2, means that there are 2 x's being multiplied together. 1, 2. Or if you could do it with a number, like, for example, 4 to the power of 3, this 3 would tell me that there's going to be 3 4s being multiplied together. So 1, 2, 3 4s are being multiplied together. That is what an exponent is. It tells you how many of the base are being multiplied together. So we're going to be looking at some different things that involve exponents. First of all, we're going to be looking at what is called a monomial. A monomial, another word for that is going to be term or terms. So if you hear me say the word term or terms, I'm referring to a monomial, which we're going to be talking about. A monomial essentially means like a single part of the problem. A monomial can be a number, a variable, and remember variable would be something like x, y, a, g, a letter. Or it can be a product of number and variables. Okay. Now, in math, the word product means multiply. So that means if I multiply a number and a variable, or more than one variable, that is going to give me a monomial. So for example, a monomial could be a number, like the number 5. It could be any number that you could think of. So a negative number is fine as well, like negative 5 would work as well. A monomial could also be a variable. So like these ones I've listed up here would be some monomials, x, for example. But also this says I could take the product of a number and the variable, and that's still going to be a monomial. So something like 5x. If I take 5 times x, that would still be a monomial, would be the monomial 5x. Okay. What we talked about earlier, this x squared over here, that is also a monomial, because x squared would be x times x. That variable times the variable, x squared would be x times x. That is also a monomial. Or again, I could have it with the number, so 5x squared would be a monomial. Or even I could put in more than one variable. So I could have something like negative 5x squared y, where there's more than one variable being multiplied together, still going to be a monomial. Things that are not a monomial would be something like addition or subtraction. So something like 5 plus x or x squared minus y. These are not monomials because the addition and subtraction separates the two different terms. It separates the monomials. So it has to be being multiplied together to be considered a monomial. Now, if we have monomials that have the same variables and the same exponents, these are called like terms. So if they have the same variables and the same exponents, these are called like terms. What we're going to be looking at today is adding and subtracting monomials. That's one of our goals for today. And in order to do that, to add or subtract monomials, we're going to do what is called combine like terms. We're going to combine like terms. So we're going to make sure that they have the same variables and the same exponents. And then if they do, we will combine them by either adding or subtracting. Here, right below there, is an important note for us to remember, especially later on. When we are adding or subtracting these polynomials, we do not change the variables and the exponents. The only thing that's going to change is going to be the number in front, but not the variables and not the exponents. So for example, on number 1, I have 17x minus 25x. These are my two monomials that I have that I'm subtracting. If we look at them, they both have the same variable x. Both of them have x as their variable. Also a note to make here, whenever you see a variable that doesn't have an exponent written, that would have an exponent of 1. So these x's that don't have an exponent, a little number in the corner, these would have an exponent of 1. So both of these have x as the variable. Both of the x's have an exponent of 1, and so they are like terms because they have the same variable and the same exponent. So these can be combined by doing 17 minus 25. 17 minus 25 is negative 8. And when we subtract these, we do not change the variables or the exponents, and so these x to the power of 1 should also be in our answer. Both of these had x to the power of 1, so we should have x to the power of 1 in our answer. So negative 8x would be my final answer there. On to number 2, I see negative 23y squared plus 6y squared. So for both of these, I see y to the power of 2. If you don't know yet, whenever you see a to the power of 2, we call that squared. So if you hear me say squared, that means we have a power of 2. Also, while we're at it, if you hear me say cubed, that means it's to the power of 3. So if you hear me say something cubed, that means it has an exponent of 3. So squared means 2, cubed means 3. So on number 2, we have negative 23y squared plus 6y squared. They both have y to the power of 2, so they are like terms because they have the same variable and exponent. They can be combined by doing negative 23 plus 6, which is negative 17. And then we don't change the variable or the exponent, so these y squareds, when we combine them, will stay y squared. Negative 17 y squared would be the final answer. Okay, number 3. I have negative 15a cubed bc plus 6a cubed bc. If I look at each of these variables, I see both of them have a cubed. Both of them have b to the first power. These would have first power because we don't see that exponent written. They also both have c to the first power. And so all of them have the same, or both of them have the same exponents on each of their variables, and they have the same variables. So they again can be combined by doing negative 15 plus 6, and that is negative 9. Our variables and exponents stay the same, and so we would have a cubed, b to the power of 1, c to the power of 1. So negative 9 a cubed bc would be my final answer. Okay, on to number 4. We have 38x squared y minus x squared y. So both of these have x squared. Both of them have y to the power of 1, and so they have the same variables and exponents. With this one, we can do 38 minus, we don't really see a number in front of the second x squared y. Whenever you don't see a number, remember that is going to be a 1 in front. So it's going to be 38 minus 1. So remember, whenever you don't see a number in front of the variable, that is a 1. 38 minus 1 is 37, and our variables and exponents stay the same, so we'll have x squared y. So far, all of our monomials that we've been adding or subtracting together have had all the same variables and exponents. But if we look at a problem like number 9, I see that I have some terms that have y, like these two, 3y and 4y, but I also have some terms that have z. So these ones do not all have the same variable. We have two different variables. What I'm going to do is I'm going to combine the two that have y. These both have y to the first power. So the 3y and the 4y both have y to the first power. When I add those together, that would give me 7y. Then I have 9z to the first power and minus 3z to the first power. So they both have z to the first power. 9 minus 3 is 6, so that would give me 6z. And since that gives me a positive 6, I'm going to put a plus sign in the middle. So I have 7y plus 6z as my final answer. Now these two can't be combined because they have different variables. The y and the z are not the same, so they can't be combined. Okay, on to number 10. We have 12b plus 8a minus 10b. So I see, again, some different variables. Looks like I have two that have b to the first power. So these are going to be the ones that can be combined. The 12b minus 10b would give me 2b. And then I have this plus 8a that I would need to bring down. I can't combine it with anything else, but I would still bring it down to be part of my answer. So I'd have 2b plus 8a. Now technically on this one, we would actually write this as 8a plus 2b. We usually like to write our answers so that the variables are in alphabetical order, and so the a would go before b. But we'll talk about more about that later on. So don't worry about it too much for now for the order, but just know that we would actually put the a before the b for this one. So we've got two more problems before I'm going to have you work on some practice problems on your own. The first, number 11, we look at all of these terms. They do all have w. I do see w for all of these. However, they do not have all the same exponent. Some of them have w squared, like these two, and some of them have w to the first power, like these two. And so, even though they do all have the same variable, they do not all have the same exponent. We can't combine them all together. What I'm going to do is combine the two that have w squared together. So 13w squared plus 4w squared would give me 17w squared. Then I'll combine the two that have just w to the first power. So I have a 9w and then a minus 31w. 9 minus 31 is negative 22, and w here is my variable. So I'd have 17w squared minus 22w. Again, these can't be combined because one has w squared and one just has w to the first power. All right, final one before you work on some practice problems. We have number 12. This one is kind of tricky because all of them do have m and n, and all of them do have a squared. So you'd kind of think that they do all have the same variables and exponents. But if you look at each variable individually, look at the 10m squared n. The squared for this term is on the m, on the first variable. If we look at the plus 7mn squared, the squared is actually on the n, not on the m. The m only has an exponent of 1. So these are not like terms because they do not both have the squared on the m. However, if we look at the last term, this m squared m, this has the squared on the m as well. So we can't combine all of these terms because even though they do have the same variables and we do have a squared on both of them, that squared is not on the same variable. So the only two that I can combine here are going to be the 10m squared n and this minus m squared n. Remember that minus would be a minus 1. So 10 minus 1 would be 9, m squared n, and then I would bring down this plus 7mn squared, which cannot be combined with the others. Okay, so now that you have these notes done for this section, what I want you to do is turn the page and go down to where you see where it says Section 1 Practice, where it says Section 1 Practice. And I want you to work on these first 9 problems. These are going to be adding and subtracting monomials just like we just did on the notes. And when you're done with these 9 problems, then you're going to turn back the page to the front side and we'll do the next section of notes in the next video. Let me know if you have any questions, and good luck.